Hi. Welcome to our presentation about cognitive empowerment through open weight LLMs as ethical smart assistants. So first, I would like to present us. My name is Kira Hout. I'm a junior specialist solution architect at Red Hat, and I am responsible for bringing applications, mainly AI applications, to the cloud. This is my colleague, Rodena. She is in charge right now of being a technical graduate, so she is currently doing what I did last year and technically doing technical things right now. But yes. So.
Yeah, I can go. So today, as Kira mentioned, we will be talking about cognitive empowerment through LLMs. So I would give you a brief introduction about what are LLMs and especially what are open weights LLMs, large language models. And then I would also would like to raise the concerns of people that have ADHD and that can use LLMs for that. And then Kira would guide us through the concerns that can be raised with LLMs for ethical and data privacy concerns. And we have prepared for you an example that we wanted to show, a local open weights large language model that can be deployed on OpenShift, and we were going to show you the technical stack that we used for it. And there's also a concept that we use that is called RAG that I would like to show you. And at the end of our session, we will give you a quick demo about the example that we are going to present to you today, and an outlook for our workshop tomorrow. And at the end, we can answer all of your questions. Okay, so by a raise of hands, who uses ChatGPT or any kind of subject? Okay, and by a raise of other hands, who knows where the data goes when you just ask a question? Who knows like how the data is being processed? Okay, yeah. Okay, so to give a brief introduction, large language models are a type of artificial intelligence, and they are being trained on a very large data set, like Wikipedia, GitHub, images, code, human comments. And through this learning, the large language model learns how to recognize a word pattern and predict the next word. So during this data set, the large language model can somehow learn statistical relationships between words and phrases and gives the users also an answer in a very informative way. So LLMs can be used for various tasks, for code translation, machine translation, speech recognition, problem solving, use cases, or what can you think of other examples?
Many things, also image generation for ad campaigns.
So there are a lot of use cases that LLMs can be used for. And like I mentioned an example of ChatGPT, there are other LLMs that are leaders in the market right now. So ChatGPT from OpenAI, Gemini, or previously Bard was launched from Google. And we have also BERT. It's a family of LLMs that also was launched and released by Google. And at the end, we have Llama. And Llama was released by Meta AI, and it's a family of autoregressive large language models. So what we wanted to focus today is about open weights LLMs. So open weights LLMs refer to the open weights of the model that are actually accessible for the users. So users can actually have access to them, can use them, update them, redistribute them. They know how the model works, they know where the data is going and how it's actually processed. And this promotes transparency between the interaction between the users and the LLM. And this kind of transparency also promotes trust between the users and LLM. And so users and developers within an AI community can engage, experiment, and collaborate on the local open weights LLMs on their local machines. So this is actually our focus today, that we want to highlight the benefits of open weights LLMs. And Kira will also raise how the concerns of privacy and how the concerns of privacy and ethics, and also especially for people with ADHD, can be raised. Yeah. I forgot about that. Okay, so here is another overview about the difference between open weights LLMs and closed weights models. So and here on the right side, you can see define like examples that include open weights models like llama.cpp. That's an open source software library written in CPP that allows you to perform inference on large language models. And there is also a Hugging Face. That's a platform that allows users developers and users to distribute and also like develop on large language models. And we have the earlier versions of OpenAI were open source. In comparison to that, we have the closed weights models, like the later versions of GPT, and Gemini, the AI chatbot that is released by Google. Yeah, and we say the yay and the nay here. Yeah.
So now a bit about ADHD and how we would try to implement these concerns into our local language assistant. So the things that we are addressing about ADHD are, for example, difficulty organizing tasks. I mean, it's not just for people with ADHD, it could also help you. Procrastination, disorganization, and inattention. Did any one of you already suffer from these things? Probably some of you. So we were actually hoping that we could build some assistant that would help us with these criteria. And we wanted to address these specifically because we wanted to attend the large language model specifically to these aspects of the disorder that disturb our natural way of living with others as neurodivergent people the most. But for now, we wanted to also address some ethical concerns because remember when you probably Google something, I have a rash on my arm or my elbow, and it's probably cancer in all cases. So we wanted to always keep your data close to you. So if Google knows you and builds your profile, it might think you have this disease or that disease based on your search history, right? So we wanted to keep those data local, and especially with diseases that are like inheritable or just generally maybe not advantageous on the working market, or in general as a person, you don't want that out about you if you are not happy to spread awareness that you have it. So this is one of the things where we found it very important that we would be able to reproduce these things. Like, for example, when you have a Google search, you might find the same, how to say it, you might have a different answer on the same question, same for ChatGPT versions, but we wanted this persistency, so reproducibility. We also wanted you to be able to see what information you give into the system, and we also want it to be accessible for everyone. So basically not that you need a GPU, not that you need expensive hardware, a data warehouse or anything. Those are our ethical concerns. And with that also the privacy concern, which is also an ethical concern for us. We wanted the data to not be stored in any servers that are not your computer. We don't want the public or Google or any other third-party provider to have access to your health data, because we are very convinced that this is your private source. And we also want you to be sure that you're not a victim of a change to regulations. Let's say the data center is in the US of the application you're using, or in, I don't know, some other country that doesn't have any laws on the passing on of this data. We think that's very important, that we can still keep this data within our reach, and we're not like risked by these changes in regulations. So for now, this is how we plan to build our stack of this application.
Yeah, so we use two things like OLAMA and llama.cpp. So OLAMA facilitates us actually to run the large language models on our local machine, and llama.cpp is the library that let us perform the inference on our large language models. Of course, we can enhance our large language model by a concept that I mentioned before that is called RAG. And in this case, we would add the llama index that helps us index through the data set that we feed into the model, or feed next to the model to be ordered to retrieve the information. And Streamlit is a tool that helps us just turn data scripts into a web application. And these are the two add-ons that we would recommend if you would like to apply the concept of RAG, which I will be explaining in the following slide. Okay, so to have a basic LLM, we need prompt engineering. So we have a system prompt where we just guide the LLM towards our desired output. And we can enhance the LLMs in two ways. Either we just put information or input files for the LLM to help us like for the retrieval. And it's the first concept called RAG. It's retrieval augmented generation. And it's basically, let's assume that we want our LLM to be an expert of fixing bikes. So we just feed the model with documentations for fixing bikes or motorcycles. And this is actually like a manual thing that we can change the input files. And in this case, our LLM can be an expert of this area and answer the questions based on the information he finds through indexing search. The other approach would be like this way, fine-tuning. And this is actually a way if you want to have the model itself trained on a domain-specific data set. So if you want to have an LLM that talks like a lawyer, so we have like certain semantics, we just train the whole model on a domain-specific area, and the LLM will talk like a lawyer, like just use the terms. Like es gibt Fachbegriffe. So this is more like of a domain specific expertise, and the RAG is more if we want to focus on a certain topic. And our example focuses on RAG. So to summarize it, RAG is a very powerful tool to enhance the LLM. It can make your answers more accurate, updated, up-to-date. Like it's based actually on the data that you feed for the LLM. And also it combats hallucinations, and that happens a lot. If you talk a lot with ChatGPT, like it honestly happens with me, it's just sometimes they give answers that do not actually match what you're expecting, and that's the hallucination that happens, and that's because the parameters are getting very high. And you can also build trust because you know where your information are from. If like Kira mentioned before, if you want to have your health data processed by the LLM or you're feeding something person, you know that your LLM will be only getting their information from this source. But RAG would be not useful in cases if you want to get creative with tasks, so you just use a large language model to get creative on a topic that you don't really know much about. Or if you really want to be efficient and fast, RAG is unfortunately an additional step in the infrastructure, as it is like an additional step in the retrieval of the information. So that's why when it comes to efficiency and fast processing, a normal or a standard LLM is more advised to use. Yeah, I would give to Kira to explain the architecture of RAG.
All right, let's make a short excursion on the architecture of RAG. So basically, I'm going to start with some PDFs you have about the subject that you're very interested in. Let's say it's the bike manual for your, I don't know, Yokohama bike, which got updated recently, and there's a new part for your model, and you don't know how to fix it, right? So you put all of these documentation into an embedding model. This will generate embeddings, which are then stored into a vector database. This vector database is then called by your query, which will also be embedded. Oh, sorry, my hand. So there's an embedding model, the same one, which will create embeddings for the query, and then their question will be asked to this vector database. It will find out via vector similarity what is the closest document to your question, semantically, basically on that type of vector calculation. Then it will fetch this relevant context. Let's say it's about the specific brake pedal XYZ. It will put this brake model text there together with your query, like how do I fix the brake pedal XYZ? And then together, this is fed to the large language model, which will then generate a response specifically from the documentation to your question, which will basically help you a lot when you're looking for a specific answer in a large text that might not be understandable to you. Could even try to system prompt it and tell me, like, explain it to me like I'm a completely technical newbie, and it will help you in the best way possible. And that's a bit about RAG architecture and how it could help you solve specific tasks. Also, in case of ADHD, let's say you have a specific issue that you want to address a bit more, then you could also use RAG depending on what your concerns are. Like if your own illness says, like, I keep forgetting things a lot, or this period of my life was really unstructured, then it might be able to help you with those specific concerns. All right, now on to the demo. So I want to show you a bit about system prompting and how we can use this to make our agent more aware of our issues. And for that, I would like to introduce you to two different types of llamas, because I wrote a system prompt for my ADHD helper, but now I'm just going to run the normal Llama 3. I hope the demo gods are with me today, but they should be. So, for example, I feel inattentive. I feel like I have no idea where to start cleaning my room. I would just say, I need to clean my room, and I need to make an appointment at the dentist tomorrow. Can you help? I hope you guys can see it, by the way. If it's too small. Yeah. Oh, oh God. Yeah, I'm trying that. It works on my on my Linux. Zoom. That was a great Zoom. Do you have any idea? Okay. I have no idea. Wow, okay. Which one was it? It's okay. Yeah. All right. Wow. Fair. All right. So this is what it would give me if I'm not doing anything specific towards it. If I'm not helping it and telling me that I have ADHD or that I'm very inattentive, it just gives me a very weirdly formatted test, but it does give me a bit of breakdown. It's not that helpful though. So now I want to show you how I would use this one. Let's make it bigger. So it was, I need to clean my room and I need to make an appointment at the dentist tomorrow. So it basically helps me. And also, it helps me with visually signifying what I have to do. I'm not sure if you can see it, but there are certain emojis there. This will actually visually, how to say it, it helps me visualize the tasks. And it also gives me a morning check-in. And it gives me tips on how to manage this throughout the day, so I'm not going to forget, because if it's just me, I'm going to turn around and not care at all anymore. But if I at least write these reminders down and just have this quick visualization that I say, yeah, okay, the house, okay, focus just one area at a time and schedule a reminder. It just gives me a bit of more support. And with the right integrations, I mean, not just the command line, but you can also start a server and do this as a mobile application. I think this would be really helpful for me because it speaks to me in a way that I would be able to understand and interact a bit more freely with. Just to compare it, this is the more colorful option, and this is the boring, the normal one, where it just basically gives me everything, but not really nicely. You can also see the difference in formatting. It's structured it way easier in smaller points, easier to digest. And I think that could help people who are really struggling with daily tasks. And I think, yeah, that's all about the demo right now. Also, of course, this is runnable on Kubernetes as a service. So I think if you want to make functions towards it, you can just build a web app around it and serve this to people. Where we see like a future outlook as well is also building into calendar apps and OS permissions. So for example, do this directly into the operating system, which would be really useful. And then we make sure we don't forget our appointment at the dentist. So yeah, those are our, okay, no, it's Safari. That's it. Thank you so much for your attention. Are there any questions that you have specifically about this topic or about AI, LLMs? Yeah. Oh, sorry. Yeah.
Did you get the text out of the PDF?
It's you can do this with. Oh God, I would show you the library. Was it Llama Index? I think there's this library called Llama Index.
Yes.
Yeah. So.
Yeah, llama.cpp.
Llama.
Yeah, llama index, yes.
Yeah. So it's a library that works with Llama integrated already, and I mean, there's different ways to do it. There's a few ways you can implement it, but it makes sense that you take the same thing that's serving your model and like take the same library that's indexing your model because there's different kind of embeddings you can use. So it makes the most sense that you Google what model you want to use first and then check if it's compatible with the one you want to, with the embedding that you want to kind of use for your vectors.
We have a repo that we prepared for yesterday, for tomorrow, and actually that's our workshop tomorrow that we wanted to tell you about at the end. So we have a repo. We prepared a repo, and it has also information about everything, how it's built, and the model itself, and how you can add PDFs and make your LLM as specialized in any topic that you would like. And this is our workshop tomorrow at 9:30 to 2 p.m. Yeah, so. Join us, please. Yeah, and yeah, back to the questions.
Yeah.
Thank you for the interesting presentation. Do you have pictures in the PDF and descriptions in the picture, and how can you get them out?
Yeah, I'm pretty sure that would be more of a multimodal approach. Right now, the text only works. Right now it's only for text. But there are a few models which already currently really well describe pictures. I would have to come back to you what model exactly, but they basically take the input as a picture and then you can get a really nice description. So what you could do as an architecture is also include this picture in your data set, but do a separate pre-processing. But I mean, if you're looking for a tutorial, that has pictures, I would suggest also taking a look at the original documentation, because when you do the vector searching thing, or the vector search, it will give you the source of the document back. So in case you want to reread something, you can always click on it, and it will show you the original source if there's a picture missing from the description. So that's one thing I would suggest. The other thing is if there's images that describe a lot. Right now in biomedicine, it's currently worked on that they are using protein pictures and they're describing them with large language models to find different ways of how the structure could be. So it goes in a lot of ways you can use it, but this would be a multi-model approach that you take an image to text, and then you work on this text, but it could technically at some point you back to an image. That was a complex explanation, but I hope it helped. Any other?
Yes, I have one more question
Yeah.
regarding the content you have used to create the embeddings for the ADHD helper. In the earlier example, you said the bike manuals, that is information which is publicly available for consumption from the users and owners of bikes. But what did you use for ADHD helper?
Yeah, currently not a lot, because I mean it would be more personal for me, like my own information, like who I am, what I'm doing, and what I have issues with. But you could technically use your own records. I'm not completely sure if it makes that much sense to add ICD-10, but it could make sense because large language models are seriously bad at health data. So yeah, they are notoriously bad at giving doctors prescriptions. So I would say it could make sense to add that in the background because it makes it more reliable. It doesn't hallucinate around the diagnosis because the diagnosis is really black and white. So I would say it could make sense to add that into it. Yeah. Yeah.
Thank you for your talk. I have a question about this Python library.
You'll go now.
When I think I've understood you correctly that you used Llama Index to generate or extract the data from those PDF documents.
Yeah.
As far as I know, this is an online service. Is this correct?
No, it's a Python library. I mean, if you have it very quickly, you can. That's probably no. That's just normal GitHub. I think this is just the Llama GitHub, but we can try to find it. Let me find Llama Index. So yeah.
Yeah, I think that you have to upload the documents.
So you can download it. I think it's also in the repo from Stefan.
Yes.
Okay, yeah, perfect. Then I will just.
We can show you the repo so you can have an overview.
Yeah,
like
perfect.
what's there. Yeah.
Yeah. Let me just find it. I hope it's there. It's not. It's never there when you need it. Yeah, so for the embeddings, yeah, I'm probably going to have to show you this like right afterwards. But yeah, cool. All right. Is that all? All questions answered? All right. Thank you. Thank you.